Aircraft navigation is a multifaceted task that is accomplished using the following systems: Global Positioning System, or GPS, Air Data Reference System, or ADRS, Inertial Reference System, or IRS, Radio Navigation Systems, Flight Management System, or FMS, ATC Transponder, and Weather Radar. The main components of the FMS are three Flight Management Computers, or FMCs. The FMCs are primarily controlled using Control Display Units, or CDUs. The CDUs are graphic components and can be displayed on any of the multifunction displays, or MFDs. CDUs are controlled using two Cursor Control Devices, or CCDs, and two Multifunction Keypads, or MFKs. Additional navigation controls are located on the Tuning and Control Panel, or TCP, and the Alerting and Transponder Control Panel, or ATP. The Air Data Reference System calculates altitude and airspeed data and sends it to a number of systems, including displays, FMS, flight controls, engine controls, and other systems requiring inertial or air data. Air data is sensed by the left, center, and right pitot probes and static ports. Individual air data modules, or ADMs, sense pitot-static analog pressure and convert it to digital values. These digital values are evaluated and voted on by the ADRS, which then sends trusted air data to the PFDs. In addition to the pitot-static system, the ADRS receives data from two angle of attack sensors, a total air temperature probe, and engine TAT sensors. Data from the center pitot-static system is also sent to the Integrated Standby Flight Display, or ISFD. If voted ADRS air data is invalid, backup airspeed and backup altitude information is displayed on the PFDs. Backup airspeed is based on angle of attack and data from the IRS. Backup altitude is provided by GPS data. If both voted and backup air data is unavailable, ISFD altitude and airspeed will be displayed on both PFDs. The 787 uses multiple ground-based navigation radio receivers, including two VOR radios, two DME radios, and two ILS radios. The VOR, DME, and ILS radios are automatically tuned by the FMC. However, they can also be tuned manually on the nav radio page on the CDU. You can display course, bearing, and distance information on each PFD and ND. Line 1 on the nav radio page shows VOR left and right tuning information, including frequency, tuning status, identifier, and current radial from the station to the airplane. The tuning status indicates how the frequency was selected. Possible statuses include P. Procedure auto-tuning means the FMC has selected the best nav aid for approach and departure guidance. R. Route auto-tuning means the FMC has selected a nav aid on the active route for position updating. A. Auto-tuning indicates the FMC has auto-tuned the radio for best position orientation. And M. Manual is displayed when the crew has entered a radio frequency. A station can be tuned by entering either the three-letter identifier or the frequency. When using either method, a radio can be entered to display a course on the ND. Courses can also be entered or changed in the course window. To return a receiver to FMC auto-tuning, simply delete the manual tuned frequency. Tuned VOR stations are displayed in green on the ND. If a course is entered on the nav radio page, it is shown as a dashed green line. If the VOR left or right selection is checked on the ND menu, the station identifier and DME is displayed on the lower left or right corner of the screen. In addition, the ND will display a green VOR pointer. VOR left pointers are shown as a single green line. VOR right pointers are a wider double green line. The FMC will auto-tune the ILS frequency and course based on the approach selected in the FMC. Manual tuning of the radio is also possible. The ILS field on the nav radio page shows the selected frequency, course, and status. If the ILS is not being used and not tuned, Park is displayed in the frequency window. When the receiver is tuned, but not yet being used, Park is shown next to the frequency and course. A is shown when the FMC has auto-tuned the radio. M indicates the ILS has been manually tuned. ILS frequency, course, and DME information displays on the PFD when an approach is selected to the active route, and the frequency has been manually tuned, or the approach has been selected and the frequency has been auto-tuned and the airplane is less than 150 nautical miles from the destination airport, or less than 50 nautical miles from the top of descent, or the FMC is in descent mode. Localizer and glide slope scales display when receivers are tuned to an ILS frequency. Pointers display when the localizer and glide slope signals are received. The localizer and glide slope pointers fill in solid magenta when the deviation is within 2.5 dots from the scale center. If nav performance scales are in view, localizer and glide slope pointers will be displayed white. An expanded localizer scale displays during approach when the airplane is within 1/2 dot of localizer deviation. The 787 is equipped with two GPS receivers, GPS left and GPS right. The GPS receivers are independent of one another, are tuned automatically, and supply very accurate position data to the FMC. The IRS adds inertial position to this data before sending it to the FMC. If the IRS becomes inoperative, the GPS will supply position and track data directly to the FMC. In this case, no ICAS message will be displayed. Individual GPS position data can be found on CDU page POSREF 4 of 4. When position is selected on the ND menu, symbols representing raw GPS left and right positions are displayed on the ND. If the GPS receivers are calculating the same position, a single symbol is displayed. In the event the GPS systems are inoperative, a prompt on CDU page POSREF 3 of 4 can inhibit GPS updating to the FMC. The IRS is made up primarily of two inertial reference units, or IRUs, and two attitude and heading reference units, or AHRUs. These components calculate the following airplane data: airspeed, attitude, heading, and position. This information is sent to and used by the following systems: displays, flight management system, flight controls, engine controls, and other systems. The IRS is controlled by the left and right IRS switches on the IRS panel. Each IRU works with the GPS data to provide hybrid GPS inertial position inputs to the FMC. The IRUs can be powered from either the battery or hot battery bus. Initial power-up of the IRUs requires the IRS switches to be on, as well as power being supplied from the battery bus. When these conditions are met, the IRUs begin a self-alignment phase. If the IRS switches are moved to off for more than 30 seconds, the units must complete a full realignment cycle before the airplane can be moved. After alignment, if primary power fails or is removed from the IRUs, the on-battery light illuminates, and a warning horn sounds in the nose wheel on the ground only. This alerts the crew that the IRS is depleting the battery. When power is initially applied to the IRUs, they enter the align mode, and the ICAS memo message, IRU align mode left and right, is displayed. The alignment process takes approximately 7 to 10 minutes at mid-latitudes and up to 17 minutes at high latitudes. During this process, the airplane should not be moved. Normally, GPS provides position data required for IRU alignment. If the GPS is unavailable, present position can be entered on the set inertial position line on the POSINIT page. When the alignment is complete, the IRS changes to the navigate mode for normal operation. If the airplane stops for an extended period, the IRS enters an auto realign mode that refines airplane alignment until it moves again. This is done by resetting velocity and acceleration errors to 0. A new lat-long position can be entered on the POSINIT page during a realignment. The IRUs also have the ability to complete an alignment in flight after an interruption in normal power. After power to the IRUs is restored, the system realigns automatically. Attitude information will be available after a few seconds, while full navigation capability is restored within 10 minutes. GPS data is necessary for this feature to function. If GPS is unavailable, the system will not align. The AHRUs, like the IRUs, provide a stable source of the following data: attitude, heading, and rate. This data is sent to the flight controls, displays, and other using systems. Even though the AHRUs do not provide an independent inertial position, they do increase the accuracy of GPS position data. In the event both IRUs fail, the NAV IRU ICAS advisory message displays. The FMC continues to receive hybrid GPS inertial position data, but in this case, the AHRUs are used to supplement GPS position. If the entire IRS fails, both AHRUs and both IRUs are inoperative. The ICAS caution message, NAV inertial system, is displayed. In this case, the GPS output provides necessary position and track data for the FMC to continue operations. Flight planning, navigation, and performance information is still available. Coupled LNAV and VNAV operations, however, are not available with the IRS inoperative. The crew should periodically use the Set Heading prompt on the CDU POSINIT page to sync the display to the standby compass magnetic heading. The FMS performs a wide range of functions, including navigation, in-flight performance optimization, automatic fuel monitoring, and providing data to the flight deck displays. The FMS uses data from the following sources to provide flight path control commands: the navigation database, airplane position, and supporting systems. FMS calculated guidance is displayed on the ND, the airspeed indicator, the altimeter, and thrust indicators. The heart of the FMS is 3 independent flight management computers. During normal operations, one FMC is tasked with all flight management functions while the other FMCs monitor. The second FMC is ready to replace the first FMC if a system fault occurs. After the second FMC is active, the third FMC becomes available as a backup. The FMCs are controlled using the interactive graphic CDU, which can be displayed on any of the MFDs. In the event all 3 FMCs are inoperative, backup navigation capability is possible using the alternate navigation feature of the tuning and control panel. If normal power is available, alternate navigation is accessed by pressing the nav key on any of the 3 TCPs. When on standby power, only the captain's TCP is available for alternate navigation. Alternate navigation data is displayed on the TCPs and the ISFD. While autopilot and autothrottles may be available, LNAV and VNAV modes are inoperative. The communication system allows two-way data link communications between the FMCs and airline ground stations. Ground stations can indicate either company dispatch or air traffic control. A downlink is the term for when data is transferred from the airplane to the ground station. Uplink is the opposite, information sent from the ground to the aircraft. Downlinks can occur manually or automatically. Uplinks are at the discretion of the airline operations dispatcher or in response to a downlink request. Request prompts on CDU pages will communicate to the ground station that an uplink is desired. Report prompts downlink relevant information on the associated page, such as route or position reports. The FMC COM menu is a quick reference for navigating to CDU pages that feature a report prompt. For more information on data link operations, consult the communications lesson. Heading reference for the AFDS FMCs, NDs, and PFDs can be either magnetic or true north. Due to magnetic variation, the system should reference true north when operating in polar regions. The heading reference switch on the overhead panel controls north reference. In normal, the aircraft will automatically change between true north and magnetic north reference depending on aircraft latitude. When operating in polar regions, the system automatically switches to reference true north. Pressing the heading reference switch illuminates true and causes the system to reference true north regardless of latitude. The FMS uses position data from a number of systems to derive a current aircraft position solution. Actual navigation performance, or ANP, is defined as the amount of uncertainty or disagreement between those systems' sensed positions. In other words, ANP equals FMS position accuracy. ANP can be visualized as a circle that contains all possible computed aircraft positions. The aircraft is assumed to be within this circle 95% of the time. Required navigation performance, or RNP, is defined as the position accuracy required for a given flight environment. During cruise flight, RNP is normally larger, meaning less accuracy is required for safe flight. RNP will usually decrease, requiring a greater degree of FMC position accuracy during the descent and approach phases. The system can also estimate the quality of its altitude determination, which is called vertical ANP. Much like lateral RNP, vertical RNP is defined as the vertical accuracy required for a certain operation within a defined airspace. ANP and RNP are displayed in text on the CDU and graphically on the PFD. Lateral RNP ANP is displayed on position reference page 2 of 4, while both lateral and vertical information is shown on RNP progress page 4 of 4. The progress page 4 of 4 displays lateral information on the left column and vertical information on the right. RNP ANP values are listed in nautical miles on the lateral line and in feet on the vertical line. RNP values default to standard values based on the navigation database, but manual entries can be made. The bottom line of this page also lists the RNP values anticipated for the approach procedure loaded on the FMC route. The CDUs are the main interface for the flight management system. CDU entries and inputs are accomplished using the associated MFK and CCD. Each CDU includes the following features: date and time display, display screen, line select keys or LSKs, scratch pad, function keys, execute key, and a CDU help window. Navigation-related features of the MFK include alphanumeric keys, space, delete, slash, and clear keys, page keys, and the execute key and light. The CDU display screen can be divided into a few core elements: page title, page number, line title, and data lines. The title field displays the current FMC page title and, if applicable, page number. The page title can be dynamic, displaying information about the operating mode of the FMC and whether the page is active or has been modified. For example, the climb page title can indicate the selected speed mode, depending on the type of climb in progress. The page number field only displays when an associated CDU title includes more than one page. If two or more pages exist, the field displays the current page and the number of total pages. Line titles appear in small font above the line data fields and identify the type of data directly below. Data lines can be populated with a number of items, including data, boxes, dashes, prompts, and selectors. The data fields display prompts or data associated with the line title. Large font indicates pilot entered data or a constraint. Small font indicates FMC computed data or constraints generated by a selected procedure. Data fields with no information are populated with either boxes or dashes. Boxes indicate a mandatory entry for proper FMC operation. Dashes indicate additional data that is optional. Prompts are indicated by caret symbols pointing to the associated line select key for activation. Prompts can be used to change the CDU page displayed, select modes, and control displays. Selectors operate like a switch, with multiple selections that can be toggled by selecting the line select key. The active state on a selector is displayed in green, and the inactive state is white. The scratch pad is below the display screen and can be used to enter up to 34 characters. This line can display any of the following: alphanumeric keyboard entries, line selected data, or data chosen using the pick waypoint function on the ND. Any data in the scratch pad will remain there if the page is changed. This allows scratch pad data to be transferred to a different page if necessary. Each data field has a corresponding line select key located on each side of the display. Line select keys are identified as 1 left through 6 left on the left side of the display and 1 right through 6 right on the right side. Line select keys are used to move data from the scratch pad to the selected field, copy data from the selected line to the scratch pad, select a page, procedure, or performance mode, and delete line data when delete is displayed in the scratch pad. If there is no user-modifiable data or selection displayed on a line, the associated line select key is displayed as a cyan outline. This indicates the line select key is inactive and may not be selected. The function keys are used to navigate between and through the various CDU pages. Selecting a key displays the associated page. Select the root function key. When multiple pages are available, the previous page and next page keys will scroll through them. The page number on the title field indicates which page is being displayed. The previous page and next page keys on the MFK perform the same function as on the CDU display. The Execute key and light will help alert the pilot when changes have been made to the FMC flight plan that have not been executed. Selecting the Execute key activates the modification and extinguishes the light. A light and Execute key on the MFK perform the same function as on the CDU display. The Help window assists in resolving data entry errors and displays FMC information messages. The window includes the following elements: window title, window text, clear message key, total messages indication, and load FMC. The title and text show message information, including data entry errors, as well as FMC alerting and communication messages. Selecting the Clear Message key removes the Help window Current Message from display. If another message exists, it will be shown until the Clear Message key is pushed again. Some messages clear automatically when the condition no longer exists. Others must be cleared manually. The Load FMC key will display when an ATC route clearance uplink has been received. Pushing the key loads the uplinked route to the FMC and clears the message. Selecting any of the alphanumeric keys enters that character into the scratchpad. The Space button enters a space in the scratchpad. When Delete is selected, Delete is entered into the scratchpad. With Delete in the scratchpad, selecting a data line will delete the data if it is able to be deleted. The slash key is used as a data separator for data entry. Momentarily selecting Clear erases the last character. If Clear is pressed and held, the entire scratchpad is cleared. This topic provides a brief overview of each function key as well as the page it displays. Understanding the display logic programmed for each key will help you understand how the FMC works. The init-ref key selects the relevant pages for FMC initialization or reference. Pressing this key during different phases of flight will navigate to different pages. During pre-flight, selecting the init-ref key will change the page to Position Initialization, Performance Initialization, or Takeoff Reference, depending on the FMC pre-flight status. Selecting init-ref after takeoff displays the thrust limit page. This allows the crew a quick method to adjust climb limits. After the aircraft reaches the top of climb, init-ref will select the approach reference page. The init-ref index page is used to navigate to a variety of FMC initialization pages. This page can be accessed by selecting the index prompt on line select key 6 left. The index allows navigation to the following pages: ident, position initialization or position reference, performance initialization, thrust limit, takeoff reference, approach reference, reference nav data, alternate, and maintenance index. Two FMC routes can be entered manually by the crew or uplinked through DataLink. These routes can be viewed and modified by selecting the route key. Since two routes may be stored in the FMC, the title will display either Route 1 or Route 2. Page 1 displays the following fields for entry: Origin Airport, Destination Airport, Departure Runway, Flight Number, and Company Route. Company routes are pre-planned routes stored by the company in the FMC database. Selecting the Route Request prompt transmits a DataLink request for a flight plan uplink. Route pages 2 and subsequent are used to enter the desired flight plan route. The VIA column displays the segment or airway that defines the route to the waypoint in the To column. If no VIA information is entered, Direct is displayed as a default when a waypoint is entered in the To column. The Departure Arrival Index displays a prompt menu for selecting arrival and departure procedures. The center column displays the departure and arrival airports from both routes, if two have been entered. Selecting a departure or arrival prompt displays all relevant procedures for the associated airport. The arrival prompt is provided for the departure airport to facilitate an easier turnback in the event of a non-normal situation. Open departure and arrival fields on 6 left and 6 right allow the crew to access procedures for any airport that is not the origin or destination. The alternate page aids the flight crew in finding a suitable alternate airport. The page displays possible alternate airports as well as time and fuel information. Selecting a prompt on the right shows more in-depth information on that alternate airport. Alternate page 2 displays a list of previously uplinked alternate airports. The VNAV key displays vertical and speed performance for the climb, cruise, and descent phases. Pressing VNAV will display one of the following pages, depending on the phase of flight: climb, cruise, or descent. All these pages include data fields for the following: vertical planning, speed planning, and constraints. Page titles are dynamic and change depending on the selected performance mode. Selecting Previous or Next Page scrolls through the 3 pages. The bottom 2 lines on these pages display prompts that can be used to navigate to other pages or select alternate FMC modes. Selecting the Fix key displays one of 4 identical Fix info pages. Each page is used to select and highlight waypoints and stations that are not associated with the FMC route. The page allows the display of associated bearing, distance, and time data relative to a selected waypoint, a radial, a distance arc, and an abeam point. Fix, info, and radials are informational only. The autoflight system cannot navigate on this information. Selecting legs displays the route legs page. This page displays and allows modifications to the lateral and vertical components of the route. If there are more than one page of waypoints, the previous and next page buttons will scroll through the route. The left column displays the lateral structure of the FMC route. The right column includes predicted and commanded vertical navigation and speed data. Possible modifications on this page include adding or removing waypoints, as well as modifying the speed and altitude profile at each waypoint. When a modification is made, the modification enunciation is shown in the title, and the erase prompt appears on line select key 6 left. The hold page allows the crew to enter a hold into the FMC route or modify an existing hold. If the hold key is pressed when a hold already exists, that hold is displayed. A new hold may be entered by selecting the Next Hold prompt and entering or line selecting the hold waypoint into the box prompts at line select key 6 left. The hold page includes all data necessary to define the hold structure and leg length. The right column also includes fields for modifying speed, altitude, and time data. When a hold is entered and executed, it is displayed on the legs page as the associated waypoint with a hold at title. If this line is deleted using the delete key, the hold is erased from the FMC. A collection of CDU data link commands and status is displayed on the FMC COM page. Page select prompts are displayed for each FMC page with access to data link data. Pressing the Progress key displays the progress pages. The progress pages feature a wide variety of reference information and navigation tools. These include waypoint crossing data, step climb data, fuel indications and predictions, lateral and vertical navigation performance data, required time of arrival predictions, and RNP data. The nav radio page displays radio tuning status, as well as tuning control for the VOR and ILS receivers. This page was discussed in detail in Topic 3, Radio Navigation. 2 ATC transponders and TCAS units are installed on the 787. These systems are controlled from the ATP and the TCP. TCAS data is displayed on the ND and PFD. TCAS will be discussed in greater detail in the warning systems lesson. Transponders provide interrogation and downlink information, such as flight number, airspeed, ground speed, magnetic heading, altitude, and GPS position. The transponder mode selector on the ATP controls transponder operation. In standby, the system is not active. The altitude reporting off position enables mode A and S, but altitude reporting will be disabled. Transponder enables modes A, C, and S. Altitude reporting is enabled. TA only selects the transponder to on with altitude reporting and activates the TCAS mode for traffic advisories. In this position, all aircraft that would have been predicted as an RA are predicted as a TA. TA-RA selects full operation of both the transponder and TCAS systems, and is the normal operating position. The ident switch in the middle of the selector transmits an identification signal. The TCP is used to enter a transponder code and select TCAS display options. Transponder codes are entered by typing them into the scratchpad and selecting the transponder code select key. Transponder system selects the left or right transponder for operation. The ident prompt operates in the same manner as the ident switch on the ATP. In the event the ATP fails, the TCP can control the transponder modes. From the main menu, select the Alert Transponder Control selector to On. Transponder modes are now displayed as prompts and are available for selection. This concludes the 787 navigation lesson.